All right, now this is a pretty tough question, so make sure you stick with me. When we're looking at this problem, it says that the velocity of a transverse wave produced by the earthquake is 5.64 kilometers a second, while that of a longitudinal wave is 9.1368 kilometers a second. And it says that a seismograph records the arrival of the transverse wave 76.2 seconds after that of the longitudinal. So when we're looking at this, we see that we have kilometers per second, which we see that that's going to be a velocity because that's distance all over time. And then we see that we have a time down there. So it could look like a very simple velocity versus time equation. But the one thing we have to understand about this is that this time is not the time that both the waves traveled. That's the time that the transverse wave, how much it took to get there after the longitudinal wave got there. Okay, when we understand about this is that both of the waves are going to travel the same amount of distance. Okay, so when we're looking at this, what we have to find out is we have to find out the original time, meaning we got to figure out how long it took to actually travel for that longitudinal wave. Okay, so when we're looking at this, we're going to have two equations. Both are going to have something similar in common, which is the distance, because they both are going to travel the same amount of distance. So when we're looking at this, we see that we have a velocity of our longitudinal wave is going to equal our distance, all divided by our time of the longitudinal wave. Okay, so when we solve this for distance, we get distance equals our velocity of the longitudinal wave times our time of the longitudinal wave. Okay, now the other wave is traveling too. The transverse wave is traveling, and the velocity of the transverse wave equals the distance, which is the same for both, all divided by the time of the transverse wave. Now, the one thing we have to understand about this is the only thing it gives us in the problem about time is that 76.2 seconds. Okay, that's how long it took for it to arrive after the longitudinal wave. So when we think of the time of the transverse wave, really what that is the time of our transverse wave equals the time of our longitudinal wave plus 76.2 seconds. Okay, now that is the time that we're going to use when we plug it in. Okay, so we're going to solve this equation as well, and we're going to solve it for distance. So we're going to get distance equals our velocity of our transverse wave times the time of our transverse wave. But remember, we're plugging this in for that. So we'll set the equations equal to each other because they both have the same amount of distance traveled. So when we're looking at this, we set everything equal to each other. Velocity of our longitudinal wave times the time of our longitudinal wave equals our velocity of our transverse wave. And remember, we're plugging this in for our time of our transverse wave, which is the time of the longitudinal wave plus 76.2 seconds. Okay, now we have an equation that we can actually solve for our time of the longitudinal wave, which is what we need. So all we have to do is plug in our variables into that equation. So when we look at this, we'll plug everything in. Velocity of the longitudinal wave is 9.1368, and that would be kilometers a second. And we're trying to solve for time of the longitudinal wave equals the velocity of the transverse wave, which we know that the velocity of the transverse wave is going to be our 5.64 kilometers a second, and I just got both of those straight from the problem, times the time of the longitudinal wave plus 76.2 seconds. Okay, now when we're solving for this, let's solve for the time of the longitudinal wave. To do that, I have to distribute that within the parentheses. So what I'm going to get is I'm going to get our 9.1368 t, time of the longitudinal, equals 5.64 times time of the longitudinal plus that 5.64 times 76.2, which is 429.768. Okay, Okay, so solve for my time and my longitudinal, and I take that 5.64, I subtract it from both sides, and that's going to bring it over to the other side. And our 9.1368 minus 5.64 TL is going to give us 3.4968 TL, which is time of the longitudinal, equals 429.768. And now all we do is we divide both sides by our 3.4968, and that will give us, and that goes to the other side, that'll give us our time of our longitudinal wave, which when we work that out, we'll get 122.903 seconds. So now I know that. Now I have the seconds of the longitudinal wave, and I know that my original equation, velocity of the longitudinal wave equals the distance all over the time of the longitudinal. Now that I have that, I plug it into my equation, I solve for distance. So distance is going to equal my velocity of the longitudinal, which is 9.1368, times my 122.903 seconds, and I will get a distance of right around 220 kilometers for the distance, something right around there.